In this video, I will teach you how to build your first CompuCell3D simulation using Twedit. So let me actually show you how to start the Twedit, which is our editor that we use in CompuCell to actually generate and modify simulations. So first we navigate to the folder where we installed CompuCell3D. In my case, it is in applications /CC3D 4.2.2, and then I will type // and I type letters TW and hit Tab key to autocomplete. Okay, there we go. So to create our first CompuCell3D simulation, we go to CC3D project, select new project, and then the dialog opens up. So here in simulation directory, we can choose any directory we want where we will store our simulations. So I have already pre-configured that it's that my simulations will be written to users m cc3d project / cc3d 4.00. I'm going to actually delete this last part, and I'm going to call my simulation first simulation. You can choose any name you want, except please do not use spaces. For simulation type, I'm going to select Python plus XML. This is the default selection. Next, I'm going to click Continue. Here we specify general properties of the simulation, so we specify lattice dimensions. By default, this is 256 by 256. Boundary conditions, lattice type, we can choose either square or hexagonal. Average membrane fluctuations in cellular pods, this is temperature parameter. It is set to 10. I'm going to leave it like this. Pixel copy range, or neighbor order for pixel copy, is set to 1. I will leave it like this. And number of Monte Carlo steps is set to 100,000. The initial cell layout will be rectangular slab. Let's leave it. Next, we hit Continue. And the reason we are leaving most of the settings as they are is because later on we can always change it. I will show you, I will teach you how to do this. It's quite easy. So next, on the next screen here, we are specifying cell type specification. So we're going to essentially create a few cell types. So I'm going to create cell type A, and again, you can use any string you want, except please do not use spaces. So cell type A, cell type B, and I will also have cell type C. And here we have interesting column here that says freeze. So if I check this box, that means that cells of cell type C will be frozen. So essentially they will be fixed shape and they will not change during the course of the simulation. I will show you that this is the case. So I'm going to hit Continue. Next screen offers us an opportunity to define chemical fields. For now, we're not going to use chemical fields, so I'm going to skip it. And on the almost final screen, we can select cell properties and behaviors. So here we can select different energy terms. For example, if we want cells to adhere to each other, we have to select contact or adhesion flags, whichever one you feel that you're most comfortable with. In our case, I'm going to select contact, and we can select constraints. So this energy term that limits those are the energy terms that limit put a limit on cell shapes. So I'm going to select volume flags, and I'm going to leave it at that. Again, if you forget any any type of energy term to be included from here, or you want to add some, new energy terms or new constraints, you can always do it after you after you construct your simulation. So I'm gonna hit continue, and at this point configuration is complete. I'm gonna hit done, and here on the left panel we see our CC3D project called First Simulation, exactly the name that we gave it. It consists of XML of main Python file, XML file where we define energy terms and properties such as average membrane fluctuation, lattice size, etc. And then we have simulation, the steppable file. If I want to run the simulation, I can right click, and from the context menu, so again I'm selecting first simulation.cc3d, the top level line from the project in the CC3D project panel. I'm gonna select it, I'm gonna right click. If you're using touchpad, you can put two fingers on the touchpad and hit and press touchpad. And then I'm gonna select open in player, and the player should open. So indeed, and the simulation should start playing. So that's exactly what we see here. So I'm gonna pause the simulation. I'm gonna zoom in, and you can see that the cells, the green and blue cells, have jagged boundaries, but the red cells are all frozen. So those are the cells of type C, and they are frozen exactly as we configured them. Alright, so this concludes this simple video, and we will continue in the next video.